Bismillahirrahmanirrahim. Assalam O Alikum. Dear student, welcome to my YouTube channel. Now, today we will start new syllabus KPK Book Foundation Physics SSC 1 Unit number 3. In Unit number 3, Dynamics, today we will discuss SLO base according to FBISC requirement numerical problems. So we will discuss in this video question number 1 to question number 3 in part 1. Now let's start the today lesson numerical problem question number 1. In question number 1 given statement 1580 kg car is traveling with the speed of 15 meter per second. What is the magnitude of horizontal net force is required to bearing the car to held in the distance of 50 meter? So, according to the given statement, first of all, we write the given data. In given data, mass m is equal to 1580 kg. Now, the initial velocity Vi is equal to 15 meter per second. Also given that final velocity it will be reached, so Vf is equal to 0 meter per second. Distance covered, that is denoted by S, so S is equal to 50 meter. According to the given statement, we can find that force required to stop the car. Force is denoted by F, so F is equal to question mark. Now we using the formula and find the force. First we find as acceleration A by using the third equation of motion. In third equation of motion, we have 2as is equal to Vf square minus Vi square. Now putting the values, then A is equal to Vf 0 square minus Vi 15 square divided by 2 multiplied by 50. So we calculate the value 0 square is 0, so minus 15 square is 225. 225 divided by 50 multiplied by 200. Then acceleration is equal to minus 2.25 meter per second. Here acceleration in negative sign denote the retardation. So retardation is also called the negative acceleration. Then we can calculate the acceleration. The negative sign shows the deceleration. Now putting the value of A in given formula, then F is equal to ma. According to the Newton's second law, force is equal to mass multiplied by acceleration. Putting the values, then F is equal to 1580 multiplied by minus 2.25. So the force is required to stop the car is F is equal to minus 3.55 multiplied by 10 raised to power 3 Newton. Now we will start the next numerical problem in question number 2. In question number 2, given statement, a bolt of mass 10 gram is fixed with a rifle. The bolt takes 0.003 seconds to move through a barrier and leave the velocity of 300 meter per second. What is the force exerted by the rifle? Now we can calculate the force. So according to the given statement, first of all write given data. In given data, mass m is equal to 10 kg. Now mass m is equal to 10 gram, that is equal to 10 divided by 1000. When we can change gram into kilogram, so divided by 1000. 10 divided by 1000, that is equal to 0.01 kg. And also given that time is denoted by small t, that is equal to 0.003 second. Now also given that the initial velocity vi is equal to 0 meter per second, but the final velocity vf is equal to 300 meter per second. Now we can find that force F. So we can find the solution. First we can find the acceleration by using the first equation of motion, because here Vf, Vi and T is given, so we can calculate the acceleration by using the first equation of motion. Vf is equal to Vi plus At. Putting the values, then Vf is equal to 300 is equal to 0 plus A into 0.003. Here 0.003 is multiplied with acceleration. On other side it will be divided. So acceleration A is equal to 300 divided by 0.003, that is equal to 100,000 meter per second, that is equal to 10 raised to power 5 meter per second square. So the value of acceleration A is equal to 10 raised to power 5 meter per second square. Now we can find the force by using the Newton's second law. Now putting the value of A in equation, then F is equal to ma. Here F is equal to ma, then F is equal to value of m, mass is 0.01 multiplied by 10 raised to power 5 Newton, that is equal to 1000 Newton. So force is equal to F is equal to 1000 Newton. Now we will start the next numerical problem. In numerical problem, question number 3. Question number 3, given statement. A 2200 kg vehicle traveling at 94 km per hour into 26 meter per second. So given value can be converted into meter per second. Then in a given statement 94 km per hour or 26 meter per second can be stopped in 20 seconds by gently applying the brakes. It can be stopped in 3.8 seconds if the driver on the brakes. That what will be the average force exact on the vehicle in both of these stops. So first of all, according to the given statement, we can write the given data, then we can calculate the required value. So first of all, in given data, mass m is equal to 2200 kg and initial velocity vi is equal to 94 km per hour is equal to 26 meter per second. In given statement, the given value also converted into meter per second. If otherwise, we can convert into meter per second. So value vi is equal to 94 km per hour is equal to 24 meter per second. Now time taken in a first case t1 is equal to 21 second and time taken in second case t2 is equal to 3.8 second. Now the final velocity, because vehicle is stopped, so Vf is equal to 0 meter per second. Now according to the given statement, we can find that force required in first case F1 is equal to question mark, and also force required in second case F2 is equal to question mark. First of all, we can find the acceleration in first case. So we find A1 by using the first equation of motion. In first equation of motion, Vf is equal to Vi plus At. Putting the values, then Vf is equal to 0 and Vi is equal to 26 plus A1 into time T1, that is 21 seconds. Now 21 is multiplying and other side it will be divided. So calculate the acceleration. A is equal to minus 26 divided by 21. So acceleration A is equal to minus 1.23 meter per second square. Then we can calculate the force in first case according to the Newton's second law of motion. In Newton's second law of motion, F1 is equal to ma1. So putting the values, then F1 is equal to 2200 multiplied by minus 1.23, that is equal to minus 2706 Newton, that is equal to minus 2.7 multiplied by 10 raised to power 3 Newton. Now we can calculate the acceleration A2 by using the first equation of motion. In first equation of motion, Vf is equal to Vi plus At. Putting the values, then 0 is equal to 26 plus A into 3.8. Here time 2 is equal to 3.8. Now A2 is equal to 26 divided by 3.8. We can calculate the value. Acceleration A is equal to minus 6.84 meter per second square. Now we can calculate the force F2 by using the Newton's second law of motion. Newton's second law of motion, F2 is equal to ma2. Putting the values, then F2 is equal to 2200 multiplied by minus 6.84, that is equal to minus 15,048 Newton, that is equal to F2 is equal to minus 1.5 multiplied by 10 raised to power 4 Newton. In other videos, subscribe our channel. In second part, we can solve numerical problem 4 to 8. Best of luck. Allah Hafiz. Now, for the average force, F is equal to F1 plus F2 divided by 2. Putting the values, F1 is equal to minus 2.7 multiplied by 10 raised to power 3 Newton plus minus 1.5 multiplied by 10 raised to power 4 Newton divided by 2. So the average answer F is equal to minus 1.42 multiplied by 10 raised to power 3 Newton. Take care. Allah.